Calculation involving the percentage yield and the theoretical yield. Whenever you hear about percentage and theoretical yield, it involves calculation involving reacting masses. Now, I want you to know something. The formula for calculating the percentage yield is actually percentage yield is equal to the actual yield all over the theoretical times 100%. So percentage yield is the actual yield all over the theoretical yield times 100. Now, when you have a question like this, the actual yield is always given to you at the question, but the theoretical yield is the one you need to calculate. And there is something you need to know. The theoretical yield is always the mass or the moles of the products. So you have to get your theoretical yield from the product side. And the theoretical yield is the maximum amount of the product. The maximum amount of the product. Now, using the question above, you can see 45.2 grams of iron metal react with excess oxygen to produce 58.1 grams of iron tetraoxide. Now, what is the percentage yield of the reaction, and then what is the percentage yield and what is the theoretical yield? Now, by solving, I said the theoretical yield is always calculated as the product. Now, let's continue. We have a simple reaction from the question iron. You have iron react with excess oxygen to give you F iron 3O4, right? Then next thing is for you to balance the equation. Of course, this topic is not about balancing the chemical reaction, but from here we have 3 ions, so I'm going to put 3 here. You can see the oxygen is 4 here, so I will put 2 here, and the equation is balanced. Now, the next thing I want to do is I want to calculate my theoretical yield. I said at the beginning of the video that at the question, 98% of the time the actual yield will be given. And so all I have to do right now is for me to calculate the mass of iron 3, the mass of the product here. Now, can you pause the video and solve it? Pause the video, you can solve it, we solve it. Now, from the stoichiometry here, the molar mass of iron here is 55.85, and the molar mass of iron 3 is 231.55. So from the stoichiometry, you can see 3 moles of iron react to give you this product. And so what is going to be is 3 into bracket the molar mass, which is 55.85. That will give you 1 mole of this product, which is 231.55 grams, right? So 3 times this. Now, from the question, we have 45.2 grams of iron metal. So they've already given us the grams of iron metal. So this is 45.2 grams of iron metal to give you what in the product. So you cross multiply. Your S is 45.2 times 231.55 divided by 3 times 5.85. That should give you 167.55. And if you should punch it, you get 62.465 grams of the product. Now, this is the theoretical yield. This is the maximum amount you can get from this reaction. And so, if you have calculated your theoretical yield, for you to calculate the percentage yield, now becomes a thing of a child's play. Now, from the equation here, we have 45.2 grams of iron metal react with excess oxygen to produce 58.1 grams of this. Now, already they have given you the actual yield. Now, all you have to do is for you to calculate and get your theoretical yield. And that is what I did. And I said again, the theoretical yield is always the mass or moles of the product. And that's why immediately I went and used reacting mass to get the mass of the product. Now, all you need to do for you to calculate your percentage yield is you just put it into this equation and your answer will flow naturally. So we have the actual yield, which is 58.1 all over the theoretical yield, which is 62.465 times 100. Now, if you punch it in your calculator, whatever you get should give you the answer immediately. So the percentage yield here should give you 92.96. So you have 92.96%, which is equals to 93% approximately. If you approximate it, what you get is 93%. Now, I want you to know something again. Always, the actual yield is always lesser than the theoretical yield. The actual yield will always have a lesser value than the theoretical yield. So those are the few points. Let's go to the second example. The second example is 30 grams of propane burns in air to produce 70 grams of CO2. Calculate the theoretical yield and the percentage yield of CO2. So, of course, I've already simplified the equation for you. You can see 30 grams of, this is a combustion reaction, by the way. Whenever an organic compound burns in oxygen, it will produce always CO2 and water, is it not? So, we have C3H8 plus O2. The product is always CO2 plus water, right? Now, the next thing is for you to balance it. You have to balance it. This is 3. This should be 3 here. Because the next thing is balance your hydrogen. Hydrogen is 8 here. So here it should be 4. And the last one is balance your oxygen. We have 6 plus 4. This is 10 divided by 2. So this is, the oxygen is 5 here. So the equation is balanced. Now, the next thing is, I will have to use the mass of propane to calculate and get the mass of the product, which is CO2. And from there, I will get the theoretical yield. Remember, I said at the beginning of the video that the theoretical yield is the maximum amount of the product. And the theoretical yield is always at the product side. And so, even the question I've already gives you an insight of what we are doing. So from here, using the reacting masses to calculate it, you can see that 1 mole of propane reacts with what? 3 moles of CO2, right? So from here, the molar mass of this compound, of course, carbon is 12, and hydrogen is 1. So times 3 plus 1 times 8, the total mass, the molar mass of this compound is 44 grams of C3H8 to give you CO2. That is 44, right? That should give you 44, but we have 3 moles here. Remember, moles is mass all over molar mass, right? And so remember, these coefficients are moles. So I want to convert it to mass. That's why I'm just going straight. I don't want to waste time on this. So mass is moles times molar mass. So that's what I'm doing. So this is the molar mass. The molar mass of CO2 is 44. So times its moles. Immediately I'm converting it to mass. So that's what I'm doing. So in case you're not understanding. First of all, I came here and I did, this is the molar mass of C3H8. But the moles here is 1. So tightening it, you still get this. But here, the molar mass of CO2 is 44. And when you times it by the moles, here, you should get it in mass. So I want to convert it to mass immediately so that it will be easy. So this is mass to mass conversion that I want to do here. So tightening it together, you have 44. 44 times 3 should give you 132. So this is 132 grams of CO2. Now, from the question, you already been given 30 grams of this. So you have 30 grams of C3H8. What is it going to give you for you to get your theoretical yield? So cross multiply. So your S is 30 times 132 divided by 44. So 30 times 132 divided by 44 should give you 90 grams. So you have 90 grams of CO2. And that is your theoretical yield. This is 90 grams. That is your theoretical yield, right? Now remember that percentage is actual yield all over theoretical yield times 100, right? Now the percentage yield, we just calculated the theoretical yield. And I told you that they will always give you the actual yield in your question. And so the actual yield there is 70 divided by 90 times 100. And I also said that the actual yield will always be less than the theoretical yield. So your percentage yield here should be this times this. So your percentage yield here is 77.7%. And that is the percentage yield. So this is easy. Whenever they give you this thing, try to convert it to mass ratio so that you can get your theoretical yield immediately in mass, and from there you can calculate your percentage yield.